It's 2 a.m. You're still awake, and right now, deep inside your brain, something strange is happening. A toxic protein, the same one found in Alzheimer's patients, is building up between your neurons. Your liver is starting to resist insulin like a diabetic's. And your immune cells, they're forgetting how to fight. All of this from just one sleepless night. Your body isn't just tired, it's changing. So what's really happening inside your body when you miss sleep? Let's rewind 24 hours and watch what actually happens. Most people think missing one night of sleep is no big deal. You'll be tired tomorrow, maybe foggy, a little cranky. What nobody tells you is that your body doesn't see it that way. To your cells, to your organs, to the intricate systems keeping you alive. One sleepless night isn't just an inconvenience. It's a crisis. It's a signal that something has gone terribly wrong. And the moment you decide to stay awake, your body launches a full-scale emergency response. Not because it's broken, not because it's weak, but because it's intelligent. Because it knows that sleep isn't rest. Sleep is maintenance. Sleep is repair. Sleep is the only time your brain can clean itself. And when you skip it, even once, the consequences begin immediately. Before we go deeper, if you want to see exactly what your brain, liver, and immune system are doing right now during those sleepless hours, subscribe to Body Biology Unveiled, because this gets detailed, and you won't want to miss what happens next. To understand what's coming, you need to meet the players. First, there's adenosine. This is your sleep pressure molecule. Every second you're awake, adenosine builds up in your brain like sand filling an hourglass. The more adenosine, the sleepier you feel. It's your brain's way of tracking how long you've been conscious. Then there's cortisol, your emergency hormone. Cortisol is what wakes you up in the morning, what keeps you alert during danger. But cortisol isn't designed to run all day and all night. It's a sprint hormone being forced to run a marathon. Next, meet your glymphatic system. Think of it as your brain's waste disposal service. It only operates at night, flushing out toxic proteins and cellular debris while you sleep. When you stay awake, this system shuts down. The garbage piles up. And finally, there's insulin, the hormone that tells your cells to absorb glucose. Right now, your liver is listening to insulin perfectly, but that's about to change. These aren't just abstract chemicals. They're the command center of your survival. And over the next 24 hours, every single one of them will be pushed past their limits. What happens next doesn't happen all at once. It happens in stages. Minute by minute, hour by hour, your body moves through a carefully orchestrated response. And each stage reveals something most people never feel, never notice, until it's too late. We're going to walk through all 24 hours. From the first moment you decide to stay awake, to the metabolic chaos at noon, to the cognitive collapse at hour 16, to what happens when you finally sleep again. Let's begin. Hour 0. You make the decision. One more episode, one more chapter, one more hour of work. Your adenosine levels are already high. Your brain is ready for sleep, but you override it. And the moment you do, your adrenal glands release a wave of cortisol and adrenaline. This is your fight or flight system kicking in. Your body interprets staying awake past your natural bedtime as danger, as if you're being chased, as if you need to survive the night. And for the first few hours, it works. You feel alert, maybe even energized. This is the mask, the illusion that you're fine. But underneath that mask, your brain cells are already struggling. Neurons communicate through electrical signals, and those signals require energy. Normally, sleep helps restore that energy, but now, without it, your neurons are burning through their reserves. By hour 2, your brain's metabolic efficiency has dropped 15%. You don't feel it yet, but your reaction time is slower. Your working memory is weakening. By hour 4, adenosine has built to levels your brain has never had to handle while conscious, but cortisol is holding the line. It's blocking adenosine receptors, preventing you from feeling the full weight of your exhaustion. You might even feel a strange second wind. But here's what you need to understand. That second wind isn't energy. It's debt. Your body is borrowing from tomorrow to pay for tonight, and the bill is coming. By the time the sun rises, you've been awake for 8 hours past your normal sleep time. And now, something shifts inside your liver. Your liver is the metabolic command center of your body. It regulates blood sugar, stores energy, processes toxins, and it relies on a finely tuned relationship with insulin. But that relationship is breaking down. Studies show that after just 12 hours of sleep deprivation, insulin sensitivity drops by 30%. 30%! That's the same level of insulin resistance seen in people with pre-diabetes. Here's what that means. When you eat breakfast, carbohydrates break down into glucose. Insulin is released to help your cells absorb that glucose. But your liver isn't listening anymore. It's resisting. So your pancreas pumps out more insulin to compensate. Your blood sugar spikes higher and stays elevated longer. And your brain, which runs almost entirely on glucose, isn't getting the fuel it needs efficiently. This is why you feel ravenous. Why you crave donuts and bagels and anything loaded with sugar and starch. It's not a lack of willpower. It's biology. Your body thinks you're starving, because in evolutionary terms, the only reason you'd be awake this long is if you were hunting, fleeing, or facing a crisis. And in a crisis, you need fast energy. At the same time, 2 hormones are going haywire. Ghrelin, the hunger hormone, spikes, leptin, the satiety hormone, crashes. Studies have measured this. 1 night of sleep loss increases ghrelin by 28% and decreases leptin by 18%. You're hormonally wired to overeat, and every bite you take is harder for your body to process. This is hour 12. You've made it halfway through a normal waking day, but metabolically, you're already in chaos. We're halfway through the 24 hours and your body is just getting started. If you're realizing how much is happening beneath the surface, hit that subscribe button. We decode this kind of biology every single week at Body Biology Unveiled. And trust me, what comes next gets even stranger. Hour 16. This is where most people hit the wall. And there's a reason why. Your prefrontal cortex, the part of your brain responsible for decision-making, impulse control, rational thought, is shutting down. Not completely, but enough that researchers have compared this level of impairment to having a blood alcohol content of 0.05%. You are cognitively drunk without a single drink. Let's go deeper. Your prefrontal cortex needs a constant supply of glucose and oxygen to function. But your glymphatic system, remember, hasn't been active. That means waste products, metabolic byproducts, beta amyloid proteins. They're all accumulating in the spaces between your neurons. Your brain is literally drowning in its own waste. And that waste interferes with neuronal signaling. Messages that should take milliseconds now take twice as long. You forget what you were saying mid-sentence. You stare at your screen and nothing makes sense. Meanwhile, your amygdala, the emotional center of your brain, is going into overdrive. Normally, your prefrontal cortex keeps your amygdala in check. It's the brake pedal on your emotions. But now, the brake is failing. Studies using brain imaging have shown that after 24 hours without sleep, amygdala reactivity increases by 60%. 60%. This is why everything feels harder. Why a small frustration feels like a catastrophe. Why you want to cry or snap at people for no reason. And here's the part that should terrify you. Your brain knows it's impaired. Deep down, some part of your consciousness recognizes that you're not thinking clearly, but you lack the cognitive capacity to do anything about it. You're trapped in a feedback loop. Too tired to realize how tired you are. Too impaired to recognize your own impairment. This is hour 18. You've been awake nearly a full day, and your brain is begging you to stop. But we're not done yet. Hour 20. While you're struggling to stay conscious, something even more dangerous is happening in your bloodstream. Your immune system is collapsing. Not entirely, but significantly. Let's focus on T cells. These are your immune system soldiers. They patrol your body, looking for viruses, bacteria, anything that doesn't belong, and when they find a threat, they bind to it, mark it for destruction, coordinate an attack, but T cells need sleep to function. Research has shown that after one night of total sleep deprivation, T cell adhesion, their ability to stick to pathogens, drops by 70%. 70%! Your immune cells are essentially blind. They're bumping into viruses and bacteria but can't grab hold. Can't neutralize them. This is why people get sick after pulling all-nighters. It's not bad luck. It's immunology. At the same time, your body is flooding with inflammatory cytokines. These are signaling proteins that usually spike when you're fighting an infection. But now, they're spiking for no reason. Your body thinks it's under attack. So inflammation rises. Your joints ache. Your muscles feel sore. You might even run a low-grade fever. It's a paradox. Your immune system is weaker and more inflamed at the same time. Hour 24. You've been awake for a full rotation of the Earth. Your brain is toxic. Your metabolism is broken. Your emotions are uncontrollable. Your immune system is compromised. And all of this from missing one night of sleep. But here's the question. Nobody asks. What happens when you finally close your eyes? The moment you fall asleep, your body doesn't rest. It goes to work. Within the first 90 minutes, you drop into deep sleep. The kind of sleep your brain has been screaming for. And during deep sleep, your glymphatic system finally opens. Cerebrospinal fluid floods through your brain, washing away the beta amyloid, the metabolic waste, the toxic buildup of the last 24 hours. Studies show the glymphatic system clears waste 60% faster during sleep than during wakefulness. Your brain is being power washed. Then comes REM sleep. And here's where your brain does something extraordinary. It knows what it lost, so it compensates. You'll spend 30 to 40% more time in REM sleep than normal. This is called REM rebound. Your brain is trying to recover the dreams, the memory consolidation, the emotional processing it missed. But even with perfect recovery sleep, you won't get back what you lost. Your insulin sensitivity will return to normal within 1 to 2 nights. Your immune function will recover within 72 hours, but the cognitive debt, the accumulated impairment in focus and memory, can linger for 3 to 5 days. Sleep deprivation leaves a shadow. Sleep deprivation leaves a shadow, and your body remembers. None of this is speculation. In 2010, researchers at Leiden University found that just 24 hours of wakefulness reduces insulin sensitivity by 30%. In 2013, a team at the University of Rochester discovered the glymphatic system and proved it only activates during sleep. In 2017, a study published in Nature Neuroscience showed that one night without sleep increases beta amyloid accumulation by 5%. And in 2019, a meta-analysis in Sleep Medicine Reviews confirmed that sleep deprivation reduces T-cell function by up to 70%. This isn't theory. This is measured, peer-reviewed, replicated science. Your body's response to one sleepless night is universal, and it's profound. So why does your body do this? Why such an extreme response to missing one night of sleep? Because your body isn't punishing you. It's protecting you. Every symptom, every impairment, every metabolic shift is a signal, a message telling you to stop, to rest, to sleep. Your body doesn't see sleep as optional. It sees sleep as survival. And when you skip it, your body pulls every emergency lever it has to get you back on track. Your body is not broken. It's responding intelligently. If you learned something new about your body today, something that made you see sleep differently, subscribe to Body Biology Unveiled, because your body is doing 1,000 things you don't notice. And we're here to show you all of them. You've just watched 24 hours inside your body, from the adrenaline mask of hour 0 to the metabolic rebellion at noon, From the cognitive collapse at hour 16 to the immune shutdown at hour 24. And finally, to the recovery that begins the moment you sleep. One night, one missed night, and your brain, liver, heart, and immune system all responded like it was a crisis. Because to them, it was. So here's my question for you. What surprised you most about this journey? Let me know in the comments. And remember, your body is always talking. You just have to listen.